So what we're going to do is with the chi-squared, we're going to look at a goodness of fit. A goodness of fit. We're going to set up a test to investigate how well a sample distribution fits a given distribution. And we're going to use the observed and the expected frequencies to compute the sample chi-squared statistic, find or estimate the p-value, and complete the test. So take a look at this example. This is a great example of this goodness of fit. Last year, the labor union bargaining agents listed 5 categories, and they asked each of the employees to mark the one most important to her or him. The categories and corresponding percentages of favorable responses are shown below. So this is a union. The people that were bargaining contracts asked the constituents, asked the people that they're representing, what is the most important thing to you? Last year, 4% of them said, hey, it's all about vacation. Because vacation's all I ever wanted. You guys recognize that phrase at all? Vacation's all I ever wanted. National Lampoon's Vacation. Wally World. Park's closed. Moose out front. Should have told you. If you haven't seen National Lampoon's Vacation, you are missing out. Go rent it. Very good.
Is it a movie?
Yeah, it's a movie. It's one of the greatest movies ever. Have you ever seen Christmas Vacation? Yeah, it's the precursor to that. And then European, it's all right. I mean, it's got some funny parts.
Okay.
But Vacation is the first one when they go across the country in the family truckster and they have Anna Edna. Okay, I digress.
National Anthem's what?
National Lampoon's Vacation. 4% of the people said vacation time. 65% of the members said the most important thing to them is salary. Money, 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 money. Which then makes me think of Donald Trump's Apprentice show. Money, 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 money. Okay, I'm not good at this. Safety regulations, 13%. 12% said health and retirement benefits, and 6% said overtime policy and pay. This was last year's data. What they're going to do is they're going to collect new data for this year, and they're going to compare it to last year's data to see is there any real big differences. The bargaining agents need to determine if this year's distribution of responses fits last year's distribution or if it's different. In questions of this type, we are asking whether a population follows a specified distribution. In other words, we are testing the hypotheses that where the null is that the population does fit the distribution, that things haven't really changed. And the alternate is that the populations have a different distribution, that things have changed. You know, in the last year, maybe the economy's really taken a hit, and the 4% that said vacation was the most important thing to them have now shifted and said, you know what's really important to me is salary. Salary, salary, salary. That's it. That's the most. And so if things have shifted or changed, that's what they're going to test. So we use the chi-square distribution to test the quote-unquote goodness of fit hypotheses. Just as with the test of independence, we're going to compute the sample statistic. So we're going to do that same process that we just started out with that question 11 we just went through, where chi-squared is found by the sum of the differences squared divided by the expected value, but the degrees of freedom is going to be k minus 1. And you're like, whoa, what's k? K, that's the phrase that Mr. Besko uses all the time, right? K? Right? Where E is the expected, O is the observed, you got the differences there, it's added up. K is the number of categories in the distribution. Okay? So the number of categories in the distribution, if we go back to the one that we had, the example, we've got 5 categories, so the degrees of freedom is going to be 4, 1 less. Next, we use the chi-square distribution table to estimate the p-value. So once we know what chi-squared is, we look it up in the table, we find the p-value, we compare it to the alpha, and then we conclude the test. In the case of goodness of fit test, we use the null hypothesis to compute the expected values. Let's look at the bargaining category problem to see how that's done. In the bargaining category problem, the 2 hypotheses are the null, the present distribution of responses is the same as last year's. Things haven't changed. The alternate is that they are different. The null hypothesis tells us that the expected frequencies, when we said that 4% of last year's people said the most important thing to them was vacation, we can compute what 4% of the number of people that we sample this year is, and that's our expected value. Let me say that again. Last year, 4% of the people said vacation was the most important. If I sample 200 people this year, the expected number of people to say vacation this year would be what? What is that? 8. We take 4% of however many people we sampled, which was 200. That would give you 8 people. So that's our expected value. We compare that to however many people actually said vacation this year. That's our observed value, however many people said it this year. Okay? So to test this hypothesis, a random sample of 500 employees was taken. So if the null hypothesis is true, then there should be 4% or 20 people, 4% of 500, 20 responses that say vacation is the most important bargaining issue. So here's what you have. You have the observed values. That first column, this is how many people this year actually said those things. We calculate the expected values by using the previous year's percentages of the number of people we sampled this year to find our expected. We then can find the difference in the difference squared and then the difference squared divided by the expected, and we can add that up, and we can find chi-squared to be 14.15. Our degrees of freedom is how many? Anybody awake? There are 4. There are 5 categories. Take out 1. There are 4 degrees of freedom. So we have our chi-squared and we have our degrees of freedom. We should be able to look it up in on the chi-squared distribution table. Larger values of the sample statistic chi-squared indicate greater differences. So the larger the chi-squared is, the more differences you have. The larger the chi-squared statistic, the stronger the evidence to reject the null hypothesis that the population distribution fits the given. So consequently, goodness of fit tests are always right-tailed tests because the chi-squared distribution is only a right-tailed test. For goodness of fit tests, we use a right-tailed test. Duh, just said that. To test the hypothesis that the present distribution of responses to bargaining categories is the same, we use that chi-squared. We look it up in the table. So let's go look that up. 14.15 with a degrees of freedom of 4. So degrees of freedom was 4. We look up 14.15. We find that it falls in between those two values there on the far right. We look at the top. We see that our p-value is somewhere between 0.05 and 0.01. Or excuse me, 0.005 and 0.01. So when we compare that to our level of significance, they haven't even told us what the level of significance is yet. We compare that to our level of significance of 0.01. Since our p-value is all less than that. Oh, thanks. I'm like, hey, those look familiar. Then what happens when the p-value is less than alpha? We reject the null. Remember what the null was. There were no differences in the categories. This test just tells us that there are differences. And we need to look in further at to what are those, because it doesn't tell us exactly which one is different. So we see that the p-value is less than alpha, so we reject the null. The interpretation is this. At the 1% level of significance, we can say that the evidence supports the conclusion that this year's responses to the issues are different. The responses this year are different than last year's. The goodness of fit test involves several steps that can be summarized in the blue thing. This is just a quick summary review of what we already discussed. And that's it. That's what section 2 is all about.